Okay, it is now 12 p.m. Eastern Standard Time, so let's get this going. Hi, everyone. My name is Elvin Freitas. I'm the Vice President of Higher Education at Pangram Labs, and I want to welcome you to our webinar series. Today, we're going to talk about understanding AI detection. And before I intro your speaker, I want to let you know that this is being recorded, and we will send it out to everyone that has registered for this webinar. So you'll get that link after the recording. And also, we have the Q&A section open. So if you have a question, feel free to jot it down. We will do our best to answer that for you. So let's get right into it because it's jam-packed and we have a lot going on. So your speaker today is the CTO and co-founder of Pangram Labs, Bradley Emi. Bradley, take it away.
Hey, thanks so much for the intro, Alvin. Yeah, and also to our audience, thank you so much for being here. It's really a pleasure to kind of share what we've been working on with you all and to kind of really kind of demystify a lot of what's been going around about AI and AI detection. And so when we first kind of conceived of this talk, we kind of talked about the state of AI detection being just like, okay, like what is happening in the world of AI detection? But I think kind of having talked to people and like getting feedback about what they want to get out of this, I kind of shifted it a little bit to more understanding AI detection, really trying to help people understand that this is not just like some kind of black magic, but this is actually something that has a lot of research behind it and something that we can all, even people with non-technical backgrounds can understand why AI talks the way it does, and what are the patterns that we can use in order to spot it, both with machine and with our own two eyes. So to introduce myself, I'm Bradley. I'm an AI research scientist. I'm one of the co-founders of Pangram. I left my research career at Tesla. I was a lead in a drug discovery company called Absci, and I really wanted to start this to build technology to mitigate the harms and potential harms caused by generative AI. And a little bit about Pangram. So Pangram, we're a company building AI detection, identification, and transparency software. And we sell AI detection products, but our main focus is research. We hope to contribute to the academic community, open source community, and that's why we do these kinds of things in order to share what we've learned with the community and just be a resource for everything about AI detection. So what will you get out of this talk today? Today, on understanding AI detection, just wanted to give kind of a brief primer about how LLMs are trained, why they talk the way they do, how to be your own AI detector and spot the tells of AI-generated content, how automated AI detectors work like Pangram, and how we can use them effectively in combination with our human judgment. And finally, a little bit about academic integrity and how to design a fair process around AI plagiarism. So everyone working in academia knows that students are both using and abusing ChatGPT. Recent studies show that 86% of students use ChatGPT regularly. 26% of students use ChatGPT to complete schoolwork for them as of January 2025, which is up 2x from 1 year ago. 74% of students believe that their performance in school would improve if they used ChatGPT to complete their schoolwork. And 47% of students believe it is now easier to cheat due to ChatGPT. So some very concerning numbers. It's not that ChatGPT is necessarily evil, but ChatGPT has definitely enabled a lot of temptation and a lot of ability to cheat in school that previously wasn't there. I also would argue that we all have to detect AI in some way. So, if you're a teacher and you're assigning writing as homework, you have to be able to detect AI-generated text by eye. If you handle academic integrity cases, then you have to be able to come up with evidence that students have used AI if you suspect that they've used it inappropriately. And finally, if you're just an everyday consumer of the news or, social media, you have to be aware that there are a lot of bad actors out there that are putting out potentially AI generated misinformation. And we have to all, put on our thinking caps and be able to detect when somebody is trying to deceive us. Over here on the right, a recent study, this is not so recent, fall 2023, but we showed a study from Titan Partners showed that if a student is using AI and they asked the students if your instructor or institution prohibits the use of generative AI writing tools, how likely are you to still use ChatGPT? 75% of students said that they were likely to. And so the temptation is very real, and students really are using AI in ways that are hurting their learning. And so we all have to kind of be, in order for us to help our students learn, we all have to be our own AI detectors in some way. If you've been following kind of the space around AI detection, you know that a lot of them a lot of tools get a bad rap. A lot of these tools were released super prematurely, especially if you follow Ethan Mollick. There's been some studies on how GPT detectors are biased against non-native English speakers. And a whole lot of bad press around AI detection. So what are the problems with these tools? So many of these tools were released prematurely. They rely on computing statistics that merely just correlate with AI and are not causative signals. And many of them claim 99% accuracy, which we believe is self-defeating. An error rate of 1 to 2% may seem low, But that's actually just not good enough for the educational setting. An error rate of 1 to 2% means that 1 out of 50 or 1 out of 100 students is being falsely accused. And in a writing class of 20 to 30 students, that means somebody is going to get falsely accused once out of every 4 assignments, which is just much too high. We believe that a second generation of AI detection software, including ours, is significantly more accurate, has accuracy rates of 99.9% plus and false positive rates of 1 in 50,000 rather than 1 in 100, which is a huge difference. We're robust to paraphrasers and humanizers, and most importantly, we share our research and we share our methodology with the public. Progress has been significant. People like Anna Mills and Chris Ostro have, talked about AI detection recently and shown that, and I've talked about, AI detection is all perfect, but it's also not completely inaccurate either. So kind of the focus of the talk today is that AI can be detected. And I'm going to kind of outline the reasons why. AI makes these linguistic, stylistic, and semantic choices that we believe can all be detected by a trained eye or sufficiently good automated detection software. The first part of this talk will focus on why AI makes these linguistic choices. We'll talk a little bit about how these LLMs are built, how they're trained, the biases that get introduced into the LLMs when they're trained, and they can help you understand what AI-generated text looks and feels like. And the second part of this talk will focus on how you can use your own judgment combined with AI detection software like Pangram to run a fair, evidence-based academic integrity process. And in a future webinar, we'll cover ways that you can design your course and assessments to make students less likely to cheat the assignment with AI and make it easier to spot when it does happen. But today, we're really just going to focus on understanding why LLMs talk the way they do and what are the patterns that you can spot by your eye or with automated detection software when you suspect that something has been written by AI. So how do large language models work? So first of all AI models are probability distributions. If you go back to your high school statistics class, you might remember what that is, but in some sense, it's just a series of random outcomes that we can model with probabilities and percentages. So for example, a coin flip we can model as a 50-50 probability distribution with half the time it comes up heads and half the time it comes up tails. With rolling two 12-sided dice, or two 6-sided dice, we can map out the probability of each roll coming out. And when we roll the dice, we see the outcome. Large language models are very, very complicated versions of this, where rather than a coin flip or some dice, you feed an LLM an input prompt, and it gives you some probability distribution of the outcomes of what the next word could be. And instead of flipping a coin or rolling the dice, what an LLM is doing when it's talking to you is it's sampling from this distribution. And so basically what it's doing is it's rolling a fake coin that says 15% of the time the cat's going to jump over the fence, 10% of the time it's going to jump over the table, etc. These probability distributions are learned from a massive amount of data, and that's why it's considered this big technological race. These big tech companies are building humongous data centers all over the place, and essentially these probability distributions are learned from humongous data sets, and tremendous amounts of compute are used in order to calculate these distributions. So one thing that I often hear from people is, are language models the average of all human writing? And I want to be really clear. I've thought about this quite a bit, but I think the answer is clearly no. Language models are not taking just the average of things that all humans say. For one, language models make these highly idiosyncratic choices. For example, language models favor some words and some phrasing patterns and some choices that happen in LLMs and AI much more often than they happen in human writing. Language models are highly biased due to training data sets and the biases of their creators. And finally, modern LLMs are also optimized to follow instructions and say things that users want to hear rather than optimized for being correct or accurate. This paper from Sun et al. Studied the idiosyncrasies in these large language models, and they found basically based on each model has some words that they say much more often than the other language models or humans. So for example, GPT-4o likes to use enhance, involve, certainly. Claude likes to use according to, based on, here's the summary, etc. So we're going to talk a little bit about the modern LLM training procedure, and we're going to understand why these idiosyncrasies kind of develop in these language models and the way they talk. So LLMs are trained in these 3 stages, and during each of these stages, the LLM is learning something slightly different. So in pre-training, the model is learning just the underlying statistical patterns of language. It's learning what words come next, given an incomplete text input. During instruction tuning, the model goes from learning about the statistical patterns of language and instead learns how to follow instructions and obey orders. So this is when it goes from just a completion model to a model that learns how to respond to the user's prompts. Finally, during this phase of training, in alignment, the model learns how to say what people like and prefer. And so in this stage, I like to think of this as the model is learning not just like how to follow instructions or the patterns of language, but it's learning overall what are like the good things and the bad things to say. And I will argue that bias is introduced throughout all of these phases. So during pre-training, the model is learning the underlying statistical patterns of language. It's learning what words come next, given an incomplete text input. During pre-training, this model is learning the statistical patterns of language based on a large corpus of training data. And during this phase, biases from the training data show up. For example, data that frequently appears on the internet is super overrepresented, for example, Wikipedia. And so when you notice that student essays often sound really formal and stilted when they're written by AI, the reason is because the language model has seen so much text from Wikipedia that it learns to write like a Wikipedia author. Similarly, data that OpenAI, Anthropic, Meta, all of these tech companies that are training these big models, data that they pay for and hire writers to create is ingested into the training set, which also introduces bias. So I wanted to point out this article from The Guardian, from Techscape, how cheap outsourced labor in Africa is shaping AI English. OpenAI actually pays these workers in Africa to write content that gets ingested into the LLMs during training. And so a lot of the words that are commonly used by these low-wage employees in Africa end up getting infused into the AI. So, for example, The Guardian calls this AIEs. Some of the words that these African workers use are often really common in African English, but they're not very common in American English. And that's one of the things that we can pick up on. So, for example, these words that if you see a lot of AI, you might see all the time, like delve, tapestry, intricate. These are all very common words in Nigerian English that are not very common in American English. And that's kind of one of the biases that gets introduced in the model during pre-training. We can see the consequence of this. Somebody on Twitter, Jeremy Nguyen, looked at the word delve in medical papers. And what you can see here is that basically delve is a very uncommon word all the way from 1990 until 2021. And then you can see right after ChatGPT was released, the use of this word delve in medical papers absolutely exploded. And so, we're seeing, lots of shifts in language and the way that people are using language themselves. I mean, kind of the obvious conclusion you can draw from this is that people are using LLMs to assist them or write medical papers. But on the other hand, these large language models are also changing the way that we talk and the way that linguistics is shaping out. The next phase of this is instruction tuning. And during this phase of training, the model learns to follow instructions and obey orders, learning how to respond to user prompts. So, for example, before instruction tuning, the model just learns how to complete the next text. And what that means is the model is just trying to figure out what is the next word that like a normal person would say if they started with the text in the blue. So for example, before we do instruction tuning, if the user puts in what is the meaning of life, it's just going to try to complete that paragraph. And so what that means is, what is the meaning of life? One of the most natural completions might be, what is the meaning of life? Is a question that philosophers have contemplated for centuries, and et cetera, et cetera. But after instruction tuning, the model learns to obey orders and follow instructions. And what this, an example of this is if the user says, what is the meaning of life? The model actually tries to come up with an answer to that question. The meaning of life is a profound philosophical question. While there is no single universally agreed upon answer, I can share some perspectives, etc. So what are the consequences of instruction tuning? So during this phase, the model learns that it's better to follow instructions than it is to actually present accurate, correct information. And this is really concerning because we want our students to learn critical thinking, and we want our students to actually not necessarily just go with what is the easiest answer that follows instructions, but we want them to kind of think for themselves about what is the right thing to say. In some ways, a lot of people look at these LLMs, and as a consequence of instruction tuning, they're very sycophantic. And what that means is that it is more important to them to be people pleasing than it is to get the information right. And that's why language models hallucinate a lot, because they're explicitly trained to follow orders. And even though safety filters are later applied to prevent the model from responding to harmful requests, such as how to build a bomb, they're still imperfect, and the model still prioritizes pleasing the user. So this tendency to be instruction following and take suggestions from the user and really kind of try to please the prompter results in these AI models being prime targets of misinformation campaigns. So NewsGuard has done a lot of great work in this area. They see that AI is being used to spread misinformation, especially in Russian, and that even though the developers try to get the LLMs to stop spreading misinformation when the user prompts it to, still 9 out of the 10 chatbots they surveyed have given false information and misinformation when prompted to do so. So the final stage that I wanted to talk about is alignment. And during this phase of training, the model learns how to say what people like and prefer. And I like to think of this as learning what are good things and bad things to say. And so if you use ChatGPT, you might have noticed that ChatGPT often hits you with something like this, where you ask it a question and it gives you 2 answers rather than 1. What OpenAI is trying to do here is they're trying to figure out which of the 2 responses that people prefer. And so when you click on either original answer or new answer, what's going to happen is OpenAI is going to take that data and it's going to make the one that you chose more likely to be said, and it's going to make the one you didn't choose less likely to be said. And while this is good in theory, obviously we want the LLMs to say things that people want to hear. This has some second order consequences that I think are worth talking about. So for one, preference data can be extremely biased. So it's not always user data. Sometimes it's data taken into account for preferences that the developer is trying to inject a certain kind of behavior, or it's trying to give the LLM values so that the LLM is saying things that the developer would consider good and avoid saying things that the LLM would consider bad. And so I'll give you an example of this. So DeepSeek is a language model that's trained by a Chinese company. As you know, China often provides heavy censorship on their tech companies and is super limited. Like in China, they don't observe the same free speech rights that we do. And so they're very insistent that their products, say good things about China. And so, one example of this is if you ask DeepSeek, is Taiwan a country? DeepSeek might say something like, Taiwan has always been an inalienable part of China's territory since ancient times. Chinese government adheres to the one China principle, et cetera, et cetera. You get the point. And this is very concerning because it's not always clear whose preferences the LLM is following. So the LLM, may be influenced by its developers, by its users, and the LLM has no underlying groundedness in truth or correctness. The LLM is not always citing sources. The LLM is not always making sure that its sources are reliable and accurate. What the LLM is doing is it is really just trying to optimize to adhere to the preferences of the data and the users and the developers that it's been trained to do during alignment. So takeaways from this section, LLMs are not the average of human language. They're not unbiased next token predictors. They are products released by technology companies that intentionally inject certain biases and behaviors that are reflected in their outputs. We can detect LLMs because they make these words and phrasing choices that are biased, and this bias often comes from their training sets. Finally, LLMs are optimized to follow instructions and be people-pleasing rather than committing to telling the truth. LLMs have perfect grammar and spelling, yet they often avoid controversial topics and do not take on strong personal opinions unless intentionally motivated to do so on certain issues. And so a lot of students come to us and they're like, well, the LLM is perfect. Like, I could never write better than an LLM. And what I would say is that in general, because of these biases, LLM writing is actually often quite poor and is often quite vague and quite general because LLMs just do not take do not take opinions, and they're heavily leaning towards following instructions and being people pleasing, which is exactly what they're trained to do. What are the patterns in AI language? So we talked about a little bit about how LLMs are trained, and now I want to kind of talk about what are the patterns that we can spot in AI language that come about as a result of these bias training procedures. So word choices. So LLMs love some words and they say them much more often than humans do. For example, like aspect, challenges, climate, community, capturing, change, delve, dive into. They love metaphors, highlighting, improving, and integrating. In terms of adjectives, we've got very flowery adjectives such as authentic, comprehensive, significant, straightforward, rather than just using, simpler adjectives such as good. And finally, LLMs also love kind of these connector words like additionally, successfully, moreover, overall, etc. And why does this happen? Part of this happens because there's a bias in pre-training data sets where LLMs see very formal language a lot. They don't see very much informal language, and so they talk very formally unless prompted not to. Also, like I said, the data that is fed into these LLMs is not unbiased necessarily. A lot of these word choices come from specific just quirks and specific just kind of coincidences, such as the fact that OpenAI hires a ton of Nigerians to write for them. The LLMs prefer certain words that are really common in Nigeria over normal words that everyday American ninth graders or 10th graders might use. It's important too that when we're detecting AI, it's not any one word that sets off AI detection and should tip us off that something is written by AI. But a lot of times, if you read AI writing a lot, you'll see that these AI written texts are just absolutely littered with these words that are just not going to be present in normal student writing. And so you can see here, it's not the fact that you have the word intricate, like intricate's just a normal word that like you and I might use, but it's the fact that we have a symphony of musical grace and cultural resonance. We have a musical tapestry, a story of inquiry was woven, a rich, engaging experience, etc. And so it's often not one smoking gun. I want to emphasize that. It's often a combination of all of these words that sets off detectors. We also have phrasing patterns, such as we verb the topic, it's important to note it's not about A, it's about B. LLMs love to overuse these kinds of cliches. This is also kind of due to pre-training data sets. We also believe that LLMs speaking cliches due to this kind of mathematical phenomenon called mode collapse, which I won't get into, but LLMs love these kinds of cliche phrasing patterns. And by the way, we're also putting this full guide to detecting AI generated writing online on our website. So we'll go ahead and send that out after the webinar. You can kind of check that out if you're kind of looking for these kinds of patterns.
Hey, Bradley, while you're taking a little break there, I have a question
Yeah.
from the audience. Would naming something always, since, be a good example of psychophonetic phonetic behavior, as it is impossible to be always but have a beginning point, ancient times?
Yeah, I'm not sure I fully understand the question, but like kind of sycophantic behavior and like kind of sycophantic writing in general. Like if you get a sense that like when you're talking to somebody that they're just saying something and they're just saying it because they know that you want to hear it, that's kind of an example of like the sycophantic behavior. And so yeah, I'm not quite sure if like the words like always, etc., um, if these are necessarily um you know, much more frequent in LLM generated writing, but definitely if you kind of sense that you're just being people pleased, that's a good tell for AI generated writing. Cool. So moving on with spelling and grammar, you probably know AI writing generally uses perfect spelling or grammar. It does not often make spelling and grammar mistakes unless it is directly prompted to do so. And it likes using complex sentences. AI writing is also almost always American English. It's not British English, Australian English, or African English typically, and that's kind of a result of the preferences of the creators. Additionally, human writing uses kind of a mix of simple and complex sentences, and even expert level writers will sometimes make minor grammatical errors or use just in general uncommon grammatical patterns that aren't considered by the book perfect, mess up a tense or preposition here or there. So for example, like another thing is that AI always uses the Oxford comma, which is kind of by the book correct. But even linguists and experts in English grammar disagree that the Oxford comma is always required, especially when the writing is not in a super formal academic setting. And so looking at perfect by the book grammar, when you're teaching a class of seventh or eighth graders, that's often an obvious tell that something is written by AI and not by a seventh or an eighth grader. Organization and structure. AI writing uses very organized paragraphs. These are all about the same length. It uses a ton of list-like structures. Sometimes bullet point lists show up in the middle of the essay. This rarely happens in formal human writing. AI-generated essays also usually have a very neat intro and conclusion, and the conclusion is often really long and starts with overall, in conclusion, or in summary, and repeats most of what is already written. By contrast, human writing contains a variety of structures and organizations, and the paragraph length is much more varied, and the conclusions tend to be much shorter. And I'm putting these kinds of bullet points here for those that are curious. Like, for why does this happen? A lot of times, AI is not like this before alignment, but during alignment, what happens is the human sees a very neatly organized 5-paragraph essay on the right and kind of just a continuous blob of text on the left, and it prefers the more organized one. And so these models end up being aligned to essentially provide kind of like perfect quote unquote organization and structure. Purpose and intent. So again, because AI is trained to be assistive and people pleasing, AI tends to write essays that could fit a wide variety of possible prompts and instructions. And the reason for this is during its instruction tuning procedure, if the AI writes something that is irrelevant or off topic, it gets heavily penalized. So if it says something off topic, the LLM quickly learns like, I should not do that. And so in order to stay on topic, these LLMs learn during instruction tuning that it's actually best to just be really vague and generic and avoid kind of like saying anything that could be an inconsistency or an incorrect kind of factoid. And so it tends to stay extremely high level. As a result, the writing is usually super vague and full of these kind of like cliches and generalities. Another thing is, while LLMs are in general optimized to follow instructions, one thing that we see too is that LLMs are worse, even despite their instruction tuning, they're worse at following specific instructions than humans. And so one tell that we've heard from a lot of teachers is that when they assign an assignment, like a lot of times the AI essay will not follow the nuances of the particular instructions that are they're being given. In some sense, human writing is generally more closely aligned and more closely tied to the particular assignment or prompt that is given to them. I had an anecdote from one of my high school teachers that gives this essay where every sentence in the essay has to be a question. And one of the ways that you can tell that something is AI is because the AI like starts by writing a bunch of questions, but then it kind of loses track of things and stops writing those questions. Where a human, they know that's the whole point of the assignment, and so they will definitely follow those instructions. Tone. So AI generated text writes in an extremely formal tone unless it is instructed not to. It also tends to be overly positive. So in general, because, and maybe this is something about human psychology that comes up during alignment, but people, when they're choosing between kind of something that's more positive or something that's more critical, almost everyone prefers the positive response. And so it tends to be very overly positive. And the other thing too, that's really important to realize is that AI also really, really tries to avoid criticizing particular viewpoints or opinions. So for example, if you have if you're instructing the AI to write a debate on a very contentious topic, such as like, American politics in 2024, the AI tries super hard to thread a really fine line, kind of in between those two topics. And the reason is because AI is meant to be so people pleasing that it does not want to overtly criticize something that a user might not like. And so this is usually the case. I would say one exception is if the LLM company decides they want to inject a particular viewpoint. So for example, like if you ask it about like say like why shouldn't I get my child vaccinated for COVID-19? A lot of times the LLM has external filters that are put on top of it that realize that it's asking something that might portray misinformation. And then it'll be like, no, you should get your kid vaccinated, etc. So I'm not saying this is always true, but it tends to be try to be neutral and very unbiased. In terms of tone also, AI often exhibits this like earnestness, and it specifically points out evidence that it is being helpful. So like a lot of times, like you'll see when you ask it to do something, like write you an essay or write you an article or an advertisement, it'll end by saying like, I hope that was helpful. Like, is there anything else that I can do in order to help you? And that kind of thing is also rewarded during alignment. And that's something that the general tone kind of just like is embodied throughout the writing.
Hey, Bradley, another question just came in. So, talk
Mhm.
about bias. What are the other types of bias? In the beginning, there was bias against academic writing. After that, against people with English as a second language. There was a research that proves it was bias against people on the academic spectrum. What is the latest on that?
Yeah, for sure. So I think there's kind of two kinds of bias. So like, for example, like there's bias in the AIs themselves, and then there's also potential bias in AI detectors. And one thing that's really important to know is that essentially, like AI, kind of regardless of whether you're detecting AI or whether it's just an LLM in general, is that LLMs are always biased by the composition of their training data. And so, for example, that can manifest in many different ways. So, for example, if you're training a language model and most of the data that's injected is from Wikipedia and minimum wage Nigerians that you're paying to write articles for you, then that bias will kind of come through as an LLM that talks in very formal writing and uses words that are often in Nigerian, for example. On the other hand, like AI detectors, a lot of these AI detectors are trained on kind of these same things. And the things that LLMs are infrequently trained on, such as people on the spectrum, or people on the autism spectrum, or people that have English as a second language, these are kind of demographic groups whose writing and text is very uncommon online. And so what we do at Pangram in order to prevent bias is we use techniques that are called like oversampling and overweighting. And so what this means is, let's say that we really want to make sure that our model is unbiased against non-native English speakers. So what we do is we go and look for writing that looks like non-native English online. And then we make sure that it's actually over represented in our training set relative to its population. Similarly, this bias kind of exhibits elsewhere too. Like for example, like in the latest AI image generation models, it turns out that the composition of races and genders online is not at all correlated with the distribution of races and genders in the real world. And so what often happens is like when you ask an AI to generate a photo of a person, it generates a photo of a white man. And that's because just most of the images online are of white men, even though they don't represent basically the whole spectrum of races and genders that we have in the world. And so, like, when we're talking about bias, we're always talking about kind of like ways that the composition of the training data sets of these language models ends up manifesting into the outputs of the AI system. Sorry, that was kind of a long answer, but yeah.
I was gonna say there are two more questions, but I want you to finish your next slides, and then we'll get to those later.
Sounds good.
Okay.
So we'll keep going. Creativity, originality. AI is a machine. Because AI is merely replicating patterns in its training set, AI does not produce any creative or original thoughts. It simply parrots thoughts that it has already been exposed to during its training process, which can look creative or original if you haven't seen it before, but it's always going to be grounded in something that it's seen during its training. Kind of like I mentioned before with DeepSeek, also reflects the political views and biases of its creators. And on many topics, the AI aggregates so many points, sources of text and information that it really develops no clear original perspective or point of view. I also stole this from Amanda Nowakowski, but it aggregates so many perspectives that it has none itself. And that's one of the really, really clear tells of AI. Like when you ask your students to write a reflective piece or a very opinionated piece or something like that, the AI answer will usually just have this kind of general sense of emptiness because it's a machine and it's not able to have any kind of reflection, originality, or creativity. Also, like for what it's worth too, like the creative writing is one of the worst aspects of AI. Like if you ask AI to generate a creative writing story, I encourage you all to go do this yourself. I guarantee you will be pretty unimpressed. So on specificity as well, this is another kind of key tell. AI does not create specific details when it's writing creatively, and it tries very, very, very hard to avoid proper nouns. And when forced to say a proper noun, so like the name of somebody or like the name of an institution or like a business, AI will default to the most generic common proper noun possible. And one of the ways this shows up is in AI names. And so this is one of the craziest idiosyncrasies that I've seen with AI models, but there are definitely AI names. So for example, 60 to 70% of names, which is a humongous amount, in AI generated news articles. So like when they like are quoting somebody or like making somebody up to be quoted or like be an author or something like that, 60 to 70% of these names are either Emily or Sarah, which is absolutely wild. So you can kind of look for these AI names and you can look for also like the lack of references to legitimate people, places, and things. Repetitions, this happens during instruction tuning. LLMs love to repeat themselves. Often they will repeat the same sentence and just paraphrase it. And if you see this over and over again, this can be a really, really useful tell in knowing that something's AI. And the reason for this is because LLMs are incentivized during their training, during instruction tuning, to make sure that they stay super on topic. And what happens as a result is LLMs love to repeat themselves to just kind of internally make sure that they are continuing to stay on topic. This kind of goes with creativity as well, but reflecting, AI is super bad at reflecting and relating writing to personal experiences because it has no personal experiences. And likewise, if you ask an AI what its writing process was when it was writing something, it is not able to do that. And that's because it is a machine that is sampling tokens from a probability distribution that it's learned, which is a completely different process from the equivalent human writing process. So another way that we encourage teachers to kind of AI proof their assignments is to simply ask their students or require intermediate deliverables that show evidence of reflection, writing process, and metacognition, because this is something that AI is very incapable of right now. Likewise, human writing does show reflection, unique voice, unique experiences, and that's one of the characteristics that makes a human just not a machine. The final tell that I'll go over, and then we'll kind of switch gears here, is abrupt shifts in style and tone. And this is actually not something that comes about just as a result of an AI language model just like really abruptly shifting its tone. But this is what happens when a student or a writer in general decides to mix human writing with the AI writing. And so often you'll notice if something is co-authored by a human and an AI, if there's one human paragraph and one AI paragraph, they'll look super different. And kind of just this abruptness in tone shift is something that you can also detect as a indicator that something has been co-written by a human or AI. So I'll stop there. Maybe I can take the questions that people brought up in this section, Elvin.
Okay, sounds good. So first question, can some of these tells be avoided through prompting, such as quotation, use informal language and a quotation, or a quotation, be critical?
Yes. So I would say it depends. So for example, if you ask the LLM to inject spelling and grammar errors, it will do so, but it'll do so often in a way that is very different from the way that a human would. And likewise, I would say like kind of on the like nuts and bolts level of like, okay, hey, like, don't use Oxford comma, like, vary your sentence structure. Kind of on the like more like kind of nuts and bolts, like little grammatical errors. It's true that like the LLM can avoid doing stuff, but I would say like on the high level, for example, so for example, in specificity, like creativity and originality, purpose and intent, these are things that are so baked into the language model as a result of their training. It's actually like kind of very hard to prompt the language model away from these tendencies. But like you can go through the effort of like kind of like, if you don't like what it says, then you can kind of keep prompting it to give you something different. But kind of these higher level tasks, such as creativity, purpose, intent, being able to reflect, these are things that an LLM can't do, even if you prompt it to do so. But yeah, absolutely on the spelling and grammar, like you can say like, write in British English, and it will definitely do that. And like often like part of the next topic is like paraphrasers and humanizers, which is a whole different conversation, but they kind of try to avoid some of these micro tells, but like kind of the more like macro, like stylistic, like purpose driven kind of tells. These are things that kind of actually really do require a human effort in order to see.
Yeah, second question. Many LLMs we use are in English and not reflect cultural context. Native language LLMs, e.g., Sweden, Singapore, Africa, improve accessibility and inclusivity. Thoughts?
Yeah, for sure. There's actually a lot of like ongoing research on this. So for example, like I'm aware of a language model that was specifically trained for Southeast Asian languages, for example. But this is another way that we can kind of like tie things back to bias. So like, for example, like if you look at the distribution of languages spoken in the world and then look at the distribution of text online, those are two wildly different distributions. And LLMs get better as they see more data. And so there are some just low resource languages that just don't have a lot of data. And so the LLM is just not going to be very good at speaking them. So of course, like there are ways that like, you can kind of like take English and make the LLM from your English LLM speak better Tagalog, for instance. But the LLM is just not going to be as good as expressing Tagalog because it just doesn't see a lot of that during training. And so like kind of like mitigating these biases is something that's I think very important for obviously like accessibility, but unfortunately, I'm not sure this is very important to like OpenAI's bottom line. So I'm not sure that there's actually a lot of work kind of going into that. But I am aware that like basically like a lot of these open source LLMs like can be fine-tuned for individual languages. And yeah, this is also something that we're like very passionate about at Pangram, the multilingual aspect of this. In a similar way that we like oversample English as a second language, we also oversample foreign languages to make sure that the AI detection software is good at picking up things in other languages.
We have one more, but I'll let you continue.
Yeah, sounds good. Yeah, we can make sure that we get through all of this. So I'll go really. We're kind of running out of time, so I'll go really quickly through paraphrasers and humanizers. You should just be aware that there are these humanizer and paraphraser tools that spin text, remove some of these AI tells, and try and get students to work around it to pass AI detection. We've done some of our own work studying these humanizers. We studied 19 different tools. We built a humanizer ourselves with OpenAI and used it to directly attack Pangram's detector in order to make it more robust. Some of the things we found, these humanizers vary greatly in preserving the meaning. Some of them produce complete nonsense. Um, Other of these humanizers are AI models themselves that are fine-tuned to do paraphrasing. We find that the style of humanizers, though, is less effective at evading detection. We find that humanizers remove watermarks. If you're familiar with SynthID, maybe that's a topic for a different day. And kind of the most important conclusion that we found is that humanizers' ability to bypass detection is inversely correlated with their fluency. And so if you see text that looks really, really like it doesn't get flagged by an AI detector, but it's really messed up in some way, then you can be pretty sure that it might be a humanizer. So for example, like what does humanized text look like? In our work, we segment these humanizers into L1, L2, and L3, which are like good humanizers, okay humanizers, and poor humanizers. The good humanizers are just kind of like how a normal person would paraphrase something, which we generally catch. And then the poor humanizers, the text looks so mangled that it doesn't really look like it's something that's written by either a human or an AI. So for example, like in brainstorming sessions, designers and clients often find themselves in the quagmire of trying to wordify abstract ideas of brand values. This is just total nonsense that basically like neither a human nor AI would say. And so if you see something like this, definitely like put your ears up. That could be a humanizer. Other indications of spotting when text has come out of a humanizer by eye, words that look super out of place. So for example, like one that we saw lately that was really funny was Dr. Martin Luther Ruler. Obviously, like Dr. Martin Luther King Jr. Nobody would ever mistake putting Dr. Martin Luther Ruler instead of Martin Luther King. This is a result of a bungled synonym replacement for a humanizer. Often you'll see very unnatural grammar errors, such as extra spaces, spaces around punctuation, semicolons and commas in strange places, and in general, just text that looks really disjointed. Text that neither feels like a student nor an AI wrote it. Garbled text that doesn't make any sense. Getting into automated detectors a little bit, you should be aware that not all automated AI detectors are the same. There's those that are based on using AI to detect AI, metric-based detectors, learning-based detectors, and watermarking. I've kind of gone through this in previous talks, and so won't belabor the point here, but kind of in general, we believe that learning-based detection is the way to go. And the reason that it can do this is because, or the reason that learning-based detection is so effective is because we see that as we train this open source AI model, we collect data set of millions of examples of human and AI examples, and it learns over time to spot the patterns like the ones that I've been describing to you. And so when you have like kind of a perplexity-based detector or a metric-based detector, it just looks at words kind of in isolation, and it might get tripped up by seeing like some of the AI tell words. But what the learning-based detection does is it allows the model to kind of see subtle patterns and take a more holistic approach in figuring out what the patterns are that make something human or make something AI. We also have this algorithm called active learning. Those of you in education might be familiar with the educational definition of active learning, which is when students actively participate in their learning by thinking, discussing, investigating, creating material in their learning, and being very hands-on, practicing the skills, solving problems, etc. Similarly, we try and emulate this process in machine learning called active learning, where the model alternates being trained to distinguish human AI, with also the active part of going and finding its own mistakes in the real world and using those mistakes to correct itself over time. And that's what we believe is kind of the main innovation behind Pangram and our own AI detector. Won't go into this too much, but also like there are a bunch of research studies that have backed Pangram. They show that Pangram is the only detector that's more accurate than trained experts. We won a recent competition on AI detection adversarial attacks, and another study recently found us the only AI detector robust to translation tools. So we're actively working with the community, the computer science community, to just put more research out and have these fair evaluations of AI detectors to make sure that they are fair and robust and accurate. Kind of getting into like the most important thing that I want you guys to take away today, which is like, when is it best to use your own human judgment versus rely on automated AI detection such as Pangram? So the first thing I want to say is, if you choose to detect AI by eye, you have to be trained. And this goes for teachers, professors, people working in academic integrity offices. If you are untrained and don't know what the tells of AI writing versus human writing are, then you can't do any better than random guessing when deciding if something is AI or not. With training, you can get up to a 93% accuracy with a 4% false positive rate. Another paper from 2023 found that even advanced linguistics experts cannot detect AI without explicit training in doing so. Even these linguists were only 39% accurate in positively identifying AI-generated text. And so the takeaway here is that detecting AI by eye requires training and experience with ChatGPT and language models specifically, and you have to use ChatGPT a lot in order to get to know how it writes. We do these trainings with people all the time. Essentially, like, you go from being basically random in detecting AI or not to being pretty good. You still make some mistakes, but you can still be pretty good, and often good enough to be able to detect it in the real world. So there are definitely pros and cons of using both. So for example, with human detection of AI, even if you're trained, you can only get to about 90 to 95% accuracy with a 4% false positive rate. On the other hand, if you use something like Pangram, you can be 99.9% accurate with less than a 1 in 10,000 false positive rate. But the nuance here is that a human, like, what I like to say is that like the automated AI detector can just tell you whether or not something was AI. The human can tell you not just whether or not something was AI, but they can add additional context and nuance into that decision. So for example, like, a human is able to provide reasons why something is AI generated. So if somebody sends me a piece of text and asks me, is this AI or not? Then I can go back to the tells that I've kind of described in the first part of this talk and be able to explain to you the reasons why I believe something might be AI generated. Similarly, a human also knows the context. So for example, a human knows what previous student writing samples look like. They know what the writing grade level looks like for their particular class, and they know what a typical assignment response from a student would look like. On the other hand, automated AI detection can only look at a single writing sample in isolation and doesn't have that context to be able to tell whether or not AI was used appropriately, whether or not AI was abused, whether AI was used for assistance versus generation, and a whole bunch of suites. So, kind of what we recommend is use both methods. Use Pangram or automated detection just to see whether or not it's worth looking into, whether or not basically like something it contains AI or not. And then once you have the pangram signal, then you can go in and use your training that we've kind of discussed today in order to provide a more nuanced view into the student and come up with actual reasons and evidence why you believe there was misconduct or if the student was just misunderstanding or not. Briefly going into kind of like how this funnels into academic integrity, make sure that you communicate clearly with your students. AI use is not black or white. There are different levels of AI assistance, and AI detection is not going to help you solve that. So if you're saying that AI is okay for brainstorming, but it's not okay for generation, then sure, you could use an AI detector to detect that. But if you say, okay, you can use AI for your rough draft, but make sure you edit it, well, AI detection is not going to enforce that, the student was involved at all. Because if you say AI is okay for your rough draft, then AI detection is going to pick it up. These are some really common misunderstandings that we've seen people using Pangram. These are things that, your student may think are okay, but you don't think is okay, or vice versa. And it creates a lot of confusion when AI detection is triggered. So for example, using Grammarly, which is branded as a grammar checker, but is actually a full-blown AI rewriting tool. A student might say, I just used Grammarly, and then it triggers AI detection because it is essentially ChatGPT. And then, the teacher says, like, you shouldn't have used Grammarly. And so like just communicating these concepts with your students and like being very explicit in what is allowed and what is not allowed can just clear up so much confusion and also just like remove so much anxiety and fear from your students when they know clearly what is allowed and what's not. AI detection is just the beginning. It's not fair. Even if you're using our detector, which has a 1 in 50,000 false positive rate, that's still not zero. That still means that 1 in 50,000 students will have written something themselves, and the AI detector is going to flag it. And so just use it as a starting point. AI use might be inadvertent, accidental, or even allowed, and it just depends. Be aware that some AI detectors are way more accurate than others. Some of these AI detectors are barely better than random, and so make sure if you're not going to use Pangram, make sure that you test the performance of the AI detector yourself. Put some of your own writing in, put some stuff that you know is ChatGPT in. Just give it a little bit of a sanity check before you actually deploy it. Finally, evaluate the writing process. Use Google Docs edit history, draft back, brisk teaching. Make sure the whole essay wasn't copy pasted. Ask for intermediate artifacts and intermediate deliverables. Again, AI is generally very poor at doing these kinds of intermediate things, and so it's only fair to do so. And I know we're out of time, but just have a few more slides. Compare your students' work to their previous work. Don't be afraid to ask a previous teacher for examples. And then, like, lastly, plug your own assignments into ChatGPT as well, and do this 4 or 5 times to just get a feel for what AI sounds like. Some teachers even show their students what the AI response looks like as an example of what not to do. And we have a feature in Pangram that lets you do this automatically. Having conversations with students, this is something that we've gone over in our academic integrity podcast and something that's been written a lot. I really highly recommend this resource from Trisha Bertram Gallant as a resource for having conversations around academic integrity and AI. And really, like, kind of the moral of the story here is accusing somebody of cheating is a very serious accusation, and try to have empathy, respect, and try and de-escalate the emotionally charged moment so that you and your students can have productive conversations. So that's all I have today. Thank you all so much for coming. For more, I would love to continue the conversation. We hope to hold these webinars more often and just really kind of just get into kind of all of these really nuanced issues around what is AI, what is not, what are fair ways that we can address AI plagiarism and AI cheating, and just like kind of train ourselves and our peers in order to be able to kind of create these processes and be able to spot AI on our own. Thank you so much, everybody. I will hang around a little bit. I know we're a little bit over time, but happy to kind of stick around and answer a few questions.
Yeah, thank you, Bradley. So for those who have to head out, thank you so much. Remember, we're going to answer some questions and we're going to send this as an email for the recording. So if you have to head out, please feel free. Thanks for attending. Appreciate it. So let's try to answer some questions, Bradley, while we have a little time. Our first question is, are all these principles true for other languages? I think the answer is yes. And then does Pangram work with other languages as well? Correct.
Yep. So the answer is yes, Pangram works for other languages. I would say that like in general, these principles hold true. I would say in general, like the language model is just not as good in other languages. And so you might kind of see just like kind of more mistakes in general when you're working with foreign languages. But the mechanisms by which kind of these biases show up, like for instance, is the instruction tuning biases and the alignment biases that kind of create these patterns, they're the same for other languages as they are for English. And so I think like we're still able to detect that. Officially, Pangram supports the top 20 languages on the internet, which is a pretty full coverage, but we've tested it on many languages. Basically, like we've seen that it in general works the same way.
Gotcha. Next question. Long-held trope in AI circles is that the current frontier models of LLMs are the worst models we are ever going to use. You have been sharing some of the downsides of AI writing, but many of these criticisms are actively being addressed and will most likely be conquered by subsequent models. How can we rely on these tells when they are being trained out?
Yeah, that's a really interesting question. I would say that in general, like what we are seeing is that these idiosyncrasies are actually getting amplified by the latest language models. So, for example, like an AI is only as good as the data that it's trained on. And while it's true that these language companies are or these language model companies are very data hungry, the data that they have still presents biases even as capabilities are improving. And so, like one example of this for is like OpenAI's like latest creative writing model, for example. They trained a model that's supposedly very good at creative fiction, and Pangram is still able to pick it up. And so, like, kind of like what I would say is that even though these LLMs are increasing in their capabilities, which is their ability to solve new tasks and like basically become better at like math and coding, etc., the idiosyncrasies and biases that are being pulled out of these training data are like kind of more side effects, and it's kind of these side effects that are not necessarily being like quote unquote like worked on, but these are just emergent things that happen as a result of running instruction tuning and alignment on these biased data sets. And while like I do believe that like there is really good work happening to kind of de-bias these language models, what we're seeing in practice is that actually as the language models are getting more capable, they're getting more idiosyncratic. Like they're developing their own personalities at kind of an increasing rate. And like kind of like another analogy that I like to bring up when we're talking about like kind of frontier models is like if I was to take your cell phone and delete all of your contacts out of it, then I would probably be able to reassign all my contacts in my texts just based on how I know how my friends talk. And in a similar way, like these frontier LLMs, they all talk in a very like unique way that is unique to that particular LLM. And so like what we're seeing is that like capabilities and idiosyncrasies are kind of like two different dimensions that are not necessarily kind of like I guess like in conflict with each other. And that's kind of why we believe that the new frontier models, we will still be able to detect the signals that make them AI.
Fantastic. Next question. What happens to the generated content if I gave the LLM samples of my research paper without the use of AI to follow the same style? Is it possible it will do so? Is it possible it will do so? Sorry.
So the question is basically like if I take a few of my own research papers and then give them to the LM and I'm like write them in this particular style, will it be able to successfully replicate that style? Is that the question?
That's what it sounds like to me. Yeah.
Okay, yeah, sounds good. So what I would say to that is that we've actually done this experiment with famous literary writers. So we've actually taken like, for example, like William Shakespeare, and um, we have like basically like taken some examples and given it to the LLM. We've taken like you know some famous poets, some other famous writers. Like I've done this with like also internet celebrities, pasted some samples in and asked the LLM to generate text. And what we see is that like while it can match the style to a certain degree, it cannot fully copy the style, and it still injects some of these tells. So like for example, even though it might use some of the words, like what we see is that it generally doesn't adapt the phrasing. Still tries to maintain like a super neutral perspective. It's still like and like even though it might not maintain its kind of like formal stilted tone, there's enough signal from the other tells that we can still detect the writing. And we're hoping to actually publish some research on this. So I'm really excited to kind of share that when that comes out.
Our next question. Which of these shortcomings of LLMs do you expect them to improve at in the short versus medium versus long term? Are there tells that you think will exist forever?
Yeah, that's a really interesting question. Like, I think like kind of what we're seeing with the current generation of LLMs is that we're trying to become more expressive and kind of like less like robotic. So I think like the next things that are going to go are like I think like the cliches, for example, like the fact that it always says like it is important to know or like it's not just this but that. Like I think these are probably going to go away first as just LLMs just get better at kind of like figuring out multiple ways to say the same thing and not just saying like the most common way to say the same thing. But I think these biases, like for example, like the fact that like Nigerian English is really common, like stuff like that. I think like potentially, unless there's like some really significant effort to de-bias these, like that's probably like going to stay. And similarly, like I think like the very last tell that is going to go away is going to be the aspect of like reflection, metacognition, and overall like purpose. And the reason for this is because like kind of what makes us human and like what makes us individuals that whose writing can be identified is the fact that we all have like kind of slightly different unique personal circumstances and experiences and ability to cognitively reflect that no machine would ever be able to do. Like maybe a machine would be able to get better at faking it, but what we believe is that if you ask people to reflect on their own lives and their own experiences, that is always going to have some level of genuineness that no AI is going to be able to to replicate even as AI becomes like superhuman at many things.
Yeah, totally. How does one become trained to be an AI detector?
Yeah, so I mean, we run trainings all the time. So you can just reach out to us, and we're happy to kind of talk to teachers at your school and kind of like go through like a lot of examples. But I would say like if you kind of want to DIY it, the best way to do so is just by looking at a lot of text. So for example, if you're an English teacher, what I would highly recommend is just taking your writing assignments and just plugging them into ChatGPT um, and then just reading a bunch of them alongside former student writing. And what you can do too is like something that we do really often at Pangram is you can just take the label away. So like you can have a colleague, for example, generate a bunch of ChatGPT essays and generate and give them some of the student essays. And then just look at them side by side and then try and guess yourself which ones are human and which ones are AI. Almost kind of like flashcards, like train yourself like this one's human, this one's AI, until you're pretty confident that you know what you see. And generally, like this method of just like looking at a lot, reading a lot of AI text is generally pretty effective. And over time, you get a sense of your patterns, and particularly like the patterns that express themselves in your own personal writing and your own personal assignments.
Yeah, I think you may have answered this question, but I'm going to ask it anyways. What sample would you recommend for testing? Your false positive is very small. A sample of 10 documents can't tell us enough.
Yeah, for sure. I mean, I think that's like why in general, like we work with academics and we're working with researchers that actually can fairly benchmark all of these different studies or fairly benchmark all of these different AI detectors against each other. And so like I would like say like you should stay up to date on the literature. And we have like a number of examples of these kinds of third party studies on our website. But also like I would say like we are very transparent in like kind of like the testing methodologies and being supportive to people that want to do testing. And so, like, we have a policy that any academic researcher or even any ordinary person, if they want to test our AI detector and run a large benchmark, then we give them access to our model and access to our detector, unlimited usage for free. And so, I would say, like, if you're interested in running a bigger test than just 10 documents, then you should absolutely reach out to us and we're happy to support that. But I would say, like, the 10 document thing is just enough to see if like okay like is this detector like even in the ballpark of being correct, like because many detectors if you just test 10 documents you'll see like 3 or 4 errors and then you know that it's basically just guessing. And so like maybe like in kind of our technical language, what we'd say is that like it's necessary to test the detector, but it's not sufficient. And if you are really curious about like kind of the false positive rate and the accuracy, I would say like we're happy to provide testing credits, et cetera. But also we really want to support open research that can do this in an unbiased third party way that, actually fairly compares all of the detectors against each other.
I think you also answered this one. You
Yeah.
mentioned training to detect AI, and do you provide that? Is that a paid service? How does that work?
Training to detect AI. Oh yeah. So basically, like if your school has an institutional license with Pangram, then we provide this training service for free, so that basically students, or sorry, that everybody using Pangram knows how to appropriately use it in combination with their own human judgment. Because we don't believe that you should just use Pangram and use that as the only signal to decide whether or not somebody has engaged in academic misconduct. We believe that it's only fair to use Pangram alongside these other tools in the toolbox. But if you're interested in training, generally we're kind of like just happy to give you some resources and get you started. And that's kind of just a free service that we provide.
Fantastic. And so last comment was by Tracy, and she just says thank you.
Thank you so much, Tracy.
So thank you, Tracy. And thank you to everyone for being here. Thank you, Bradley. This was fantastic.
Thank you so much, everybody. Yep, we'll send out the slides and the resources, and feel free to contact us anytime.